Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. In the yesterday's session, we had discussed one of the colligative properties, and that was the relative lowering of vapor pressure. In today's session, we are going to discuss the another colligative property, and that is elevation in boiling point. Okay, yes, so let us see. So it depends upon, just give me a second. So it belongs to the chapter solutions and colligative property. Today we are going to discuss another colligative property, elevation in boiling point. Elevation, elevation, that is rise, increase. Elevation in boiling point. Yesterday we discussed relative lowering of vapor pressure. What is the meaning of vapor pressure? That also I have explained to you in detail with the help of experiment. RLVP. Okay, RLVP is equal to delta P1 divided by P1 naught, that is equal to x2. Okay, this was the equation for the relative lowering of vapor pressure. Yes, and then today we are going to discuss the next colligative property, elevation in boiling point. So colligative properties are what? Those properties which depend on only number of solid particles but not the nature of solid particles, right? Just give me a second. Yes, so let us discuss the elevation in boiling point today. So what is the meaning of elevation? So elevation is nothing but increase in the boiling point of the solution after mixing of the non-volatile solute. So here also we are going to discuss the same thing. and that is nothing but mixing of volatile solvent and non-volatile solute, right? Yes, so we are taking a volatile solvent, we are going to mix it with the non-volatile solute, and we'll get a solution. Okay, yes, so what will happen to the boiling point of the solution after we are mixing the volatile solute and volatile solvent and non-volatile solute with each other, that part we are going to discuss in today's class. Okay, so with the help of same experiment I can explain this to you. First of all, let us see what is the meaning of boiling point temperature of any liquid, right? The definition which we have learnt in school was the temperature at which the liquid boils, right? But that is not the correct definition. That can be called as a correct definition, but that is not the perfect definition, right? Okay, so let us see the meaning of or the definition of this boiling point, the proper definition of this boiling point. Okay, so this is the boiling point temperature is the temperature at which vapor pressure of the solution or vapor pressure of the liquid is equal to the atmospheric pressure. Okay, it is the temperature at which vapor pressure of the solution or the liquid becomes equal to the atmospheric pressure, right? So that is called as the boiling point temperature, right? So let me write down that boiling point, the temperature at which the vapor pressure of a liquid becomes equal to the atmospheric pressure, becomes equal to the atmospheric pressure. Atmospheric pressure is nothing but 1.013 bar. Okay, this temperature is known as boiling point temperature of that liquid. Okay, yes, so this is called as the boiling point temperature. So vapor pressure should be equal to the vapor pressure of the atmospheric pressure. Vapor pressure of the liquid, that should be equal to the atmospheric pressure, right? That is the boiling point. Now one statement here I am going to write down: when a non-volatile solute is added to a volatile solvent, the boiling point of resultant solution, boiling point is elevated, right? Boiling point is elevated means what? If 10 degree is the boiling point, 10 degree Celsius is the boiling point temperature of liquid, pure liquid. If we are adding non-volatile solvent, then the boiling point of the solution will be greater than 10 degree. This is called as elevation of the boiling point, right? This is called as elevation of the boiling point, right? Now to explain this, let us see its mathematical expression. Okay, let us consider, let T be naught. Okay, T stands for temperature, B stands for boiling, naught stands for pure. Okay, let T be naught is the boiling point of TB naught is the boiling point of pure solvent, is the boiling point of pure solvent. Okay, then TB is the boiling point of solution after mixing non-volatile solid. Okay, is the boiling point of solution. TB naught is the pure solvent. TB is the boiling point after mixing non-volatile solid to it. That is, it is a solution, right? Solution. Then, in that case, elevation of boiling point will be equal to delta TB, right? Delta stands for different, TB boiling point temperature. Delta TB, delta stands for different. So greater is this one, right? Because boiling point is increased. So I'll write down TB first. So it will be equal to TB minus TB naught, right? It will be equal to TB minus TB naught, right? Okay, so this is the first equation. Now one more statement here I am going to write down. So and that is nothing but, as this is a colligative property, it depends on number of particles and not on the nature. Number of particles, that is concentration of the particle, depends on number of particles, that is the colligative property, right? Okay, according to experimental observations, right? Yes, so that part I'll write down. Experiments have shown, experimental analysis, experiments have shown that for dilute solution, dilute means very less amount of solute, large amount of solvent. For dilute solutions, the elevation of boiling point, that is delta TB, elevation of boiling point, that is delta TB, is directly proportional to the molality of solution. Molality is denoted by small m, molality of solution, right? What is molality? We know that molality, not molarity, okay? It is molality is equal to small m is equal to number of moles of solute. N stands for number of, these formulas we have already discussed, divided by weight of solvent, okay? Divided by weight of solvent in kg, okay? So this is nothing but the molality, right? Therefore I can write down the equation, right? Delta TB is directly proportional to small m, right? Now here I'll put a one sign proportionality constant. Delta TB will be equal to, here I'll put the sign KB, K capital, B small, B subscript. Okay, so what is this KB here? So here KB is the proportionality constant. It is having one name. It is called as boiling point elevation constant. It is called as boiling point elevation constant, or it is also called as molar elevation constant, or it is also called as ebullioscopic constant. Okay, ebullioscopic constant. Ebullioscopic constant. Right, now let us see what is the unit of ebullioscopic constant. Unit of KB. Okay, what we know the equation, delta TB is equal to KB multiplied by M. That therefore KB will be equal to what? KB will be equal to delta TB divided by M. Delta TB is nothing but the temperature, right? Okay, temperature unit is Kelvin, and molality unit is, the number of moles is denoted by mole. Okay, therefore unit will be equal to mole per kg, right? This is the unit for molality, mole per kg. Okay, so it will be equal to mole per kg, right? Mole will go up, kg also will go up, so kg will become positive, so it is Kelvin kg mole inverse, that is the unit of delta TB. Okay, yes. Now this that is the unit for kb, ebullioscopic constant. The value of this kb is fixed for that particular type of the liquid, right? Nature of the liquid changes, the value of this liquid changes, right? It depends on the nature of that liquid, right? Okay, now this is about the first of all elevation in boiling point. Now after this we are going to see how this is related to, or by using this delta TB, how we are going to find out the this one. Yes, how we are going to find out the molar mass of unknown solid. Okay, that part we are going to see. Before that, you just take a screenshot of this page. Take a screenshot of this page. Okay, take a screenshot of this remaining portion also. Okay, yes. Now let us see the use of this delta TB for finding out the molar mass of unknown solid. There should be use of every thing, every concept which we are learning. There should be use of it in day-to-day life, right? Okay, so let us see determination of molar mass of unknown solute by using elevation of boiling point. Okay, so what is the meaning of it? For an example, there is I'm doing some kind of research on discovering a new molecule. I found a new molecule somewhere and I don't know its identity, right? So I want to find out what is the formula of that compound, what is the name of that compound, what elements are present in it. So therefore this kind of discovery starts with the determination of molar mass of that compound, because as we know molar mass is also the different for different molecule. It depends on the formula of that compound. So if we know the molar mass, then we will be able to reach to the structure of that particular unknown solute. I don't know that what is the nature of that compound, right? If that compound is non-volatile, in that case I can find out its molar mass by using this experiment. Whatever this calculating the boiling point of liquid solvent, any solvent you can take in which that unknown substance is soluble, you can calculate its boiling point separately in pure state, then mix some amount of this unknown solute to that liquid, prepare the solution, calculate the boiling point separately, and you can find out this molar mass very easily, right? That is the use of this technique. Okay, so let us see how to find out the molar mass of unknown solute by using the elevation of boiling point, right? What we know about elevation of boiling point? Elevation of boiling point, delta TB is equal to Kb into M, right? As we know, delta TB, which is nothing but elevation of boiling point, is equal to Kb multiplied by M. What is M here? M is nothing but the molality, right? M is molality. The formula for molality is the number of moles of solute divided by the mass of the solvent, right? Mass of the solvent. So here for mass of the solvent, I'll take the symbol M2, right? Okay, first of all let me just write down the symbols here. Okay, yes, so here let us assume the N solute is number of moles of solute. Then the M1 W1 is the weight of or mass of solvent. Okay, then W2 is equal to mass of solute. And M2 is molar mass of solute. Number 2 is for solute, number 1 is for solvent, right? For an example, if we have this combination, okay, we are mixing solvent plus solute, right? Volatile solvent plus non-volatile solute. Okay, in some books the number 1 and 2 are given as a symbol. In some books X and Y are also given. You can use as per your convenience. Okay, yes, 2 is for solvent and 2 is for solute, 1 is for solvent, right? Okay, so these are the symbols. Now I'll just modify the molality. Therefore molality will be equal to, as I know, molality is number of moles of solute divided by mass of the substance in kilogram, right? Okay, mass of the solvent in kilogram, that is W1 in kilogram, right? W1 in kilogram. Okay, now here I'll write down this is in kilogram. Okay, but if assume that the mass is not in the kilogram, if it is in the gram, in that case what will be the formula? It will be number of solute divided by W1 if it is in gram multiplied by 1000, right? This is the formula we know. Okay, now here number of moles also I can find out separately, right? Number of moles of solute, what is the formula for number of moles? Number of moles is equal to given weight divided by molecular weight, right? Or molar mass. Given mass by molar mass, this is how I will write down. Given mass by molar mass, right? Given mass means whatever mass of the solute and solvent we have taken. So this is the mass of the solute, right? Number of moles of solute we are finding. Mass of solute is W2 and molar mass of solute is M2, right? Okay, so this I will put in the above formula. Therefore molality will be equal to what? W2 divided by M2 divided by W1 multiplied by 1000, right? Okay, so it will be equal to, M2 will go down, W2, or first I will write down 1000. Okay, 1000 multiplied by W2 divided by W1 into M2, right? Okay, W1 into M2. Now this I will put, this molality I will put in the delta TB ka equation, right? Delta TB is equal to Kb into M, right? Therefore delta TB will be equal to what? Kb into M, right? Kb into M. So Kb will remain as it is, so it will be equal to Kb multiplied by M. Instead of M I will write down 1000 multiplied by W2 divided by W1 into M2, right? W1 into M2. Now this I can modify, because what is the desired thing we want for equation for M2? M2 is the molar mass of unknown solute. M2 will be equal to what? Yes, Kb will remain as it is, multiplied by 1000 multiplied by W2, right? Divided by delta TB multiplied by W1, right? Okay, so this is the final equation which we want for finding out the molar mass of unknown solute, right? Okay, that was the main purpose of performing this experiment, right? What is the experiment? Like we do not know the molecular formula of unknown substance. We have found unknown substance, we want to study that, right? So we will study it by first of all calculating its molar mass. What we are going to do, we will take known solvent, right? Known solvent means what? Whose properties like boiling point will be known, right? Boiling point of known solvent will be known, pure solvent. Okay, so from the boiling point of pure solvent here, right, from the boiling point of pure solvent we can find out the delta TB. How? We are going to mix the unknown solute which is non-volatile in it, stir it, make a solution, and we'll get a solution. The solution ka boiling point will be called as TB. Now we have boiling point of pure, boiling point of solution. By using these two things we can find out delta TB, that is elevation of boiling point, TB minus TB naught, right? Okay, now this delta TB, again here we are going to use it in this formula. Kb is the elevation velioscopic constant, which is a fixed number for each and every liquid. As the solvent is known, for example, if I take ethyl alcohol, so ethyl alcohol's Kb value will be fixed. Okay, so therefore I can put this value here, delta TB here. W1 is the amount of solute which we take. Obviously we will weigh it and take it, so this is known. W2 is also known, right? W2 is the weight of the solute, that also we will weigh and take. Then we can find out M2. What is M2? M2 is the molecular mass of unknown solute, unknown non-volatile solute, right? Therefore by using this experiment we can find out the molar mass of unknown solute very easily, right? Now they ask the question based on this equation, So this is very important equation. By using this equation we can find out the molar mass of unknown solute. Okay, yes, so they asked the question based on this. Okay, yes, so take a screenshot of this page. Take a screenshot of this page. Okay, so what type of question they will ask? They will ask the question like for example, an unknown solute is mixed in ethanol or in water or in any other solvent whose boiling point is this boiling point of solution. Also they will give the amounts of solute and solvent weights W1 W2 also they will give, Kb they will give. So we have to find out M2 by using this equation, right? How we can find out M2? First of all, by using TB and TB naught we can find out delta TB, right? And delta TB we will put it in this equation. M2 is equal to Kb into 1000 into W2 divided by delta TB W1, right? So this is how we can solve the question based on this formula. So this formula is very important. So that's all about elevation in boiling point. So I hope it is clear to you. If you have any questions related to elevation or boiling point, please let me know in tomorrow's class. So before ending the class, just let me show you about DPP, daily practice problem. So this is a teacher's portal. Go to the resources, then to the writing material, then open a DPP, daily practice problem. You can see the questions over here, and those write down the solutions of this question on your notebook. Take a picture of your notebook and just upload it on the portal, so that teacher will evaluate and let you know the suggestions and corrections wherever required. Okay, so that's all for today. So we are I hope today's session you like the today's session. If you have any doubts, please let me know in tomorrow's session. Please feel free to ask any type of doubt. Okay, thank you so much students for your precious time, and thank you for joining. All the best to you, and thank you so much. Bye, take care.